So good morning, and let's talk about the grandstand and also the indoor sports stand. So first of all, we're going to talk about the grandstand. Okay, so grandstand, which is created by Graham Graham in 1884, which is did the Cleversella ammonium she find this is gram-negative lots. So this is first time which is documented the grandstand. And the grandstand is a differentiate stand. Which is very simple to categorize all the bacteria into two categories, which is gram-positive and gram-negative. Now, gram-positive will be stained purple or blue, and gram-negative will be stained pink and red. Now, this is for bacteria. But how about for yeast and mold? For yeast and mold, it's a little bit different. For yeast and mold, for fungi, we all say gram stain blue. Okay, so this is a basic knowledge. Now, what are the major steps of the gram stain? Now, first of all, you need to do the smear preparation. This is all the same, including air dry heat fixing. Now, the major step of the gram stain, which is including, number one is crystal violet. This will stain 6 seconds. The function of the crystal violet is just like a basic dye to put the color there. The second is gram iodine, also stain for 60 seconds. Now, the function of the gram iodine, we call it a mordant, which means we will make crystal violet stain strong. Okay, now the third step, which is we call it a decoloration using 90% alcohol. This process we call it decoloration. And the last step, we're using this decoloration very picky, 10 seconds. You can't do too much, too long, it will be all washed off. Last, we do saffron. Saffron is also for 60 seconds. This is we call counter stain. Okay. This is the procedure. Now, gram stain very important. The procedure you have to follow. The time is flexible. You must follow the same procedure, but you can do 45 seconds or 30 seconds. That's okay. It's not a big deal. But the decoloration, that 10 seconds is very important. Okay? So this is the second. How are we going to do the gram stain? Now, then we have a very important question. That's a question people always going to ask. Why gram stain positive is blue and purple, and the gram stain negative is pink and red? So there are two theories about that. Okay, so the first theory we call cell wall theory. Now this is we're going to go back to review a little bit what we have regarding the structure and also the structure of the bacteria cell wall. So we have to go back to review a little bit that part. So let's say we have a bacterial cell wall. Let's say it's a gram-positive bacterial cell wall. What is it going to be looks like? So take this out. Okay. This everybody knows. That's a cell membrane system. What is it composed by? Which is phospholipids, double layer. And then with some of these, we call it protein. So this is called fluid mosaic model. Okay. Protein inserted into phospholipids. And remember the phospholipids, what we're going to talk about these right here. This is hydrophilic and hydrophobic. Okay, so that's two tails. Like water and dislike water. Now the protein, most of them in the channel bacteria are going to come in, or the nutrients going to come in. Then, for gram-positive bacteria, you will see there is a very heavy area right there. That is called peptidoglycan. And we already talked about peptidoglycan is the polysaccharides composed by amino acid cross-linked with modified sugar, which is N-acetylglycosamine and N-acetylmuramic acid. So MAM and NAG, cross-linked. Okay. This area for gram-positive bacteria is very heavy. Very, very heavy. Now up above, what are you going to see? You see some of these, no, not really, some of these, and you see some of the structure right there, okay? Some of them like this. These we call teichoic acid, and the function is unknown. Okay, so there is a theory, which is we say gram-positive bacteria has a very heavy peptide glycan. So you add a crystal violet there. You add a gram iodine, which makes crystal violet stay strong. Then during the decoration process, that heavy peptide glycan will be protect the crystal violet. So it will not be decoration. And then when you do the counter stain, it's not going to be show up. So gram-positive bacteria, when you see the purple color, actually is crystal violet color. Okay, so this is gram-positive bacteria. The cell wall theory. Now, second theory, we call it lipid theory. Now, this is going to talk about which is gram-negative bacteria. So what is lipid theory? Here all the same. You know that this fluid mosaic model, this looks exactly the same. Okay, that's cell wall structure. Cell membrane structure, sorry. That looks exactly the same. Now we know that compared to gram-positive bacteria, gram-negative bacteria, this is very thin. So we have a thin peptidoglycan. Okay? But what's the difference with up here? You're going to have those structure. That's called porine. Okay, the function is unknown. But then you also should know. There is a double layer there. Okay? So for gram-negative bacteria, they also have another double layer. So we call it an outer membrane system. This is called outer membrane. Okay? Now, what's the difference between gram-positive and gram-negative is right just on the top right here. Here, we have a very important structure called the LPS, lipopolysaccharides. Lipopolysaccharides composed by lipids A and polysaccharides. This lipids A is important. Because of this lipids A, gram-negative bacteria has 10 to 15% lipids. And the gram-positive bacteria is only have less than 3 to 5% lipids. So, because you have a heavy lipids, so you have a crystal violet, you have a gram iodine. When you do the decoloration, the 95% alcohol will be decoloring crystal violet because of the 10 to 50% of the lipids. Lipids is easy to be dissolved in the alcohol. So together with the lipids and the crystal violet, they all mix together and all dissolved together. So actually you should know when you put the lipids there, it will make it easily to be decoloration because lipids is easy to be dissolved in alcohol. Okay? Now at this moment, using 95% alcohol decoloration, it's all black, no color. So then you come to Shen, you see the saffron in color showed up. So actually gram-negative bacteria is the saffron in color. That's why it is pink. Okay? So this is the story behind that. Now, because of the gram stain is really based on the cell wall structure. So gram stain, you have to use very young culture, which means it's going to be a fresh bacteria, less than 24-hour new culture. Because if it's old, if it's more than 48 hours, what's going to happen? The cell wall structure will be breakdown. It will all stem gram-negative. We say it's a gram variable stem. Okay, so that's what we need to know about that. Now, last thing. When we follow the procedure, we do the gram stain. We're going to recording 3 important items. What are the 3 important things here for recording? I'm going to take this one off. It's a very important thing for recording, right here. You're going to have to record gram reaction. Positive or negative. This is most of you will remember. Second, is morphology. And we mentioned about that, which is the encoding coxal rods. Last one is arrangement. These are the three important items you must have during the gram stain. Because in the clinical areas, that's determine what a pathogen it is. Okay? So this is almost the whole story for the gram stain. If university is open after September 25th, when you come in, I will skip this part, so watch the video first, and watch the demo online first, at my YouTube channel. When we come in here, we will directly to do the gram stain. And we will do the comparison between Staphylococcus aureus versus E. coli. Okay, you're gonna figure out which one is gram positive, which one is gram negative. Tell me their morphology and their arrangement. Okay, so this is all about gram stain.